All right, so for your do now today, we're going back to triangles, and this is our new unit module 3. And the first thing you'd like to do is go ahead and sketch an acute angle, a right angle, and obtuse angle. And then if you know the perimeter of a triangle, see if you can figure out what the value of x is. This is not in your packet. So after having paused the video and reminding yourself what an acute angle is, please remember that all the measures are going to be less than less than 90 degrees. For a right triangle or right angle, you should have a box in the corner, and then an obtuse angle should be an angle larger than 90 degrees. I don't know why I drew a triangle, but an acute angle is going to be smaller than 90 degrees. Next it says the perimeter of a triangle ABC is 47 meters. Okay, so we know that P perimeter equals 47. And AB is 2x plus 6, BC is 3x plus 8, and AC is x plus 3. What's the value of x? Well, perimeter is actually part plus part plus part. In this case, it's going to equal our whole of 47. So I'm just going to fill in all my parts, which is 2x plus 6 plus 3x plus 8 plus x plus 3. So we're going back to algebra. So those of you that really liked the algebra we did in Unit 1, this unit's going to be very familiar to you. So then remember, you combine your like terms. There's an invisible 1, so that's 5, 6x. And then 6 plus 8 plus 3, that's 17. Now I'm going to subtract 17. And you get 6x equals 30 divided by 6, and x equals 5. Now if I go back to my question, they wanted the value of x. They didn't want any of the side lengths. So I don't have to plug it back in. I just know that x equals 5. Okay, now if you look at your packet, you'll notice that on the first page, you'll see a bunch of pictures, and you'll see examples and counterexamples. So what I'd like you to do first is look at all the pictures, the examples and counterexamples for each term, generate your own definition for each term, and because you're working on this alone, you won't have an opportunity to work with a partner, but you can definitely check your answers with somebody in class later on. So once you've looked at all the terms and the examples and counterexamples, I'd like you to write your own definition for each term. So for example, if I look at an acute triangle, and I look at my examples, and I look at my counterexamples, as my counterexamples, I'll notice one of the angles is 90 degrees, and one of the angles is 100 degrees. And since I know an acute means less than 90, I'm going to say it's a triangle whose angles measures are less than 90 degrees. That's my definition for acute triangle. If you're struggling, you may also look the words up on Google. The second thing you're going to need to do, this is not in your packet, is a sticky note matchup, and you'll see the sticky notes around my room, on the windows, on the walls, and you want to, as a follow-up, go ahead and match the picture with the term it describes, and have me check it to make sure that you did it correctly. And then you want to get lesson 16, or I'm sorry, activity 5. It's a separate sheet of paper, and it gives some direction. So for example, the first one says, you want to draw, label, and mark a figure described below. Of course, I'm struggling. Okay, so I'll just start a new page then because it's not letting me do what I want to do. So it says sketch, label, and mark. This is activity 5. And this is number 1. So it says I'm going to draw an isosceles triangle. Well, what do I know by an isosceles triangle? Well, I know that two sides are congruent. So how do I mark that? I put little tick marks to show that those two are congruent. And I know that these are called my base angles. So these are my base angles. And this is my vertex angle. And it says my vertex angle is M. So I know M has to go there. So that means N would go here and P would go here. So P and N are my base angles, and I have marked them because they're also going to be congruent to each other. And you're going to do that for the other, for numbers 2 through 8 as well. Okay. All right, moving forward. So let's now apply what we know. So what we know from Unit 1 is that all angles in a triangle add up to 180 degrees. Okay? So now our whole is always going to be 180 degrees. And when you're looking at a triangle, you know there's always going to be 3 angles. So we're always going to be thinking in our mind, part plus part plus part equals 180 degrees. Okay? So let's look at what we've got. We've got a situation where we want to find our missing angle. So it's going to be 40 plus 50 plus the other part, which we don't know. So I'm going to call this x, equals 180. So you just combine your like terms. That's 90 plus x equals 180. When you go across the equal sign, you subtract 90 from both sides. So I know that x equals 90. So in this case, this would be a 90-degree angle. And if I wanted to name this triangle, I would call it a right triangle. So that's your model problem. You should be able to do the other 3 problems just like that one. Let's move on to numbers 5 through 6. For 5 through 6, you want to solve for x. And again, we're looking at part plus part plus part equals 180 because there's a total of 180 degrees in a triangle. And so if I were to set up this equation, it would be x plus 58 plus 60 plus 70, and all that's going to equal 180. So the first thing I would do is combine my like terms, which are right here. So x plus 50 plus 60, 58 plus 60 plus 70 is 188. And that's going to equal 180. So I just subtract 188 from both sides because it's an equation. And so I get x equaling -8. Now it is okay for x to be a negative. What is not okay is if you plug it back in and you get a negative. Okay? So if I plug -8 back into this angle right here, it'd be -8 plus 58, and that equals 50 degrees. So I'm okay because though my x value is negative, the angle measure is not. You should be able to do all the other 3 problems modeling this. Please remember that whenever you see this symbol right here, the number that you're going to use to represent that symbol is 90. Okay. Moving forward, for the next set of examples, it says find the value of x. So now we have to use what we learned about an equilateral and a scalene triangle. Okay? So for an equilateral triangle, you should remember from your definitions that all 3 sides are congruent, which means all 3 angles are also congruent. So we just use an arc to measure that. So if this is 60, this is 60, and this is also 60. And that's just something we know because if all angles and all sides are congruent, there are 3 angles. So 3 goes into 180 60 times. So if I said that this side length was 5, this side length would be 5, and this side length would be 5 as well. Let's look as well at number 12. Okay, number 12, this is an isosceles. So let's remember this is called equilateral. Now this side has 2 marked sides. So this is what we call an isosceles. All right. If I know that this angle here and this angle here, these are what we call our base angles. And they are congruent. So this would be part equals part. So if this part's 55, this part is 55 degrees. Now be careful with number 13. This angle is congruent to this angle because those are my base angles. So this one's 45 degrees. So now when you think of it, you've got to do part plus part plus part equals 180 degrees. So be careful because sometimes they'll give you what we call a vertex angle, and sometimes they'll give you a base angle. And now at this point, you should be able to finish numbers 13. You'll notice number 14, this right here is the vertex angle. And these are the base angles, so this would be part equals part. Okay, moving forward. All right, so these are where we get a little bit more complicated, but still completely doable. So the first thing you got to do is I look at all 4 of these pictures, and I see all of them are isosceles triangles. Okay, so for angle 1, I just got to determine, do I have base angles or do I have a vertex angle? And so you'll notice in 19, 20, and 21, you have one base angle. This would be your base angle because it's across from this side. And this would be your base angle because it's across from this side. This is my vertex angle. So you have to do part plus part plus part equals 180. And so if I know this part is 9x plus 8, then I know this side is 9x plus 8. So you got to add all 3 parts together. 9x plus 8 plus 9x plus 8 plus 74, and all that's going to equal 180. So I got 18x plus, when I add those other parts together, I get 90. So subtract 90 from both sides. You get 18x equals 90. So x equals 5. And if they want to find the measure of angle 2, you're going to plug it in here. So it would be 9 times 5 plus 8. So that should be 9 times 5 is 45, plus 8 is 53 degrees. Now if you look at number 20 and number 21, you're going to solve the same way. Part plus part plus part equals 180. And one of your parts is going to repeat because these are my base angles. And you'll look here, this one's upside down, but these are my base angles. 22 is a little different. These are both base angles. So this one's going to be part equals part. So when you set this up, it would be x plus 70 equals 65. And again, you can get a negative answer. You just can't, you can't get a negative angle. So work through finish those pages. So you're finishing pages 3 and 4. And then your exit ticket is here. I'd like you to sketch each of the following. Now you're not sketching a right angle, you're sketching a right triangle. An isosceles triangle and an equilateral triangle. And then you're also going to solve number 2. You can do this on a sticky note and then turn it into me so that I know that you know what's going on. So if you're on track, you'll have page 3 and 4 done in your packet, and you'll have done all the other extra activities we did in class. Okay, good luck.